Hi, welcome back to Sound School. This is the first lesson in audio engineering, the basics of sound. In order to effectively manipulate sound as audio technicians, we need to comfortably understand how sound is created and how it functions physically. So what is sound? Well, sound occurs when physical events cause air pressure changes that our ears pick up. Our ears are capable of sensing very small pressure changes, tiny fluctuations that we perceive as distinct, recognizable sounds. So a sound event is a physical action that creates enough of a pressure change to be observed by our ears. A really obvious sound event that we can use right now as an example is a hand clap. You can probably imagine how that creates a change in air pressure. So let's take a closer look at what's happening after that sound event. So these are air molecules at rest. They're not totally motionless. Particles are always active, but they're not in enough motion for any changes to be perceived by our ears. Something has to make them move enough that our eardrum notices. Now let's think about our sound event. It strikes, and the force from the event pushes the molecules together, or compresses them. You get a group of molecules pushed together, and then as those push together, behind them comes a group of molecules that get pulled apart as the wave moves through the air. So you have to visualize this wave of pressure as spherical, outward from the event. Also, recognize that this wave will lose intensity as it passes through space and time. This repeated wave of high and low pressure can be really easily charted on paper as a sine wave. The sine wave shows the peaks, which are the waves of high pressure or compression when the molecules get pushed together, and it also shows the valleys, which are the waves of low pressure or rarefaction when the molecules get pushed apart. We can then draw a line through the sine wave at the point where there's no pressure change to represent the particles at rest. Now we can refer to the period of compression as positive pressure above the line and the period of rarefaction as negative pressure below the line. The negative pressure zone will always be equal and opposite to the positive pressure zone, as the molecules pull apart while the wave moves through the air. So now we understand how perceivable sound is created, and how that relates to the idea of a waveform.